Hi, you guys. I am coming at you from home, hoping to get your algebra lesson to you, both homework and lesson, today. Like I said in the email to you, I'm going to record for 30 minutes. At 30 minutes, I plan on stopping, and we'll just pick up tomorrow wherever we left off. So what I'd like for you to have with you today would be the folder that I gave you guys with the homework and the lessons in it. And I always start my lessons by going over the homework first. I know that sounds silly, but I like to get that out of the way so you guys know what's expected of you. So I'm going to be flipping screens for a little bit here, so you're going to have to bear with me. It's going to be a little bit strange. So go ahead, open up, and you can always pause this video. This is kind of learning at your own pace. So open up your that little folder that I gave you, open it up to the homework section. It should be in the back. I kind of separated things with colored paper. And you're looking for the homework that is titled 1.1.1. And remember, we discussed how homework is labeled. It looks like it's got that little crazy 8 at the top, and it says preview and review on it. I'm looking at my homework right now. Review and preview. I'm going to go ahead and flip the camera and give me a few minutes to kind of fumble through the screens for a second. So I'm going to go out of there, and hopefully you're still hearing my voice. And this is the homework. So you can see right there, it says review and preview at the top. And the assignment is 1.1.1, and it lists the problems that you will be doing. So right now I haven't taught you anything yet, but you're going to see at the top, it's question 1-4, and I'm going to read this to you, and you're going to highlight a few things so that you know what to expect. So give me a few minutes while I fumble through with my pen and make sure that everything is working. Okay, so the question number 1 says, Angelica is working with function machines. She has the 2 machines shown below. She wants to put them in order so that the output of the first machine, so we're talking about the output, and we are going to go through this in the lesson, but the output is always your Y value. We're going to go over this in the lesson in just a second. She wants to put them in order so that the output of the first machine becomes the input of the second. Input is always your X value. We're going to go through this in detail in just a minute. She wants to use a beginning output. I think I said that wrong. She wants to use a beginning input of 6. So we're going to highlight that too. So that means she wants to start with an input of 6. And in question number 1, it says, in what order must she put the machines to get a final output of 5? That means we want the final Y value to be 5. So you can see here that I labeled each of your machines number 1 and number 2. So you're going to do some work down here to put your input of 6 in to get an output of 5. Now I'm going to tell you, you might need to do some trial and error. If I were you, I would start with this one, and I would do an input of 6 and see what my output is. Then that output becomes your input. And will you get an output of 5 when you do it that way? I don't know. That's for you to tell me. If it doesn't work, then you need to do it again, but this time you would start with number 2. And you would do an input of 6 here and see what happens when you put the output in here into number 1. So you're going to have to play around with that, but I left you some room at the bottom of the page to do the work. And hopefully when we go through the lesson, you'll see what I mean by that. Scrolling to the next problem. You might have done tiles in Math 8. It says explain the tile pattern below. So I gave you 3 tiles, figure 1, figure 2, and figure 3. We want you to sketch figures 4 and 5 right here. So what would the next figure look like? So count the number of tiles that you see and decide how each figure is growing. So I see that I have 3 here, and then however many I have here, I'll write that number, and then however many I have here. And then that will determine how many tiles you will have in figure 4 and how many tiles you will have in figure 5. So all you have to do is write that down, do a drawing of each figure. Then part B says, how does the pattern grow? In other words, how many tiles are you adding each time? And then tell me where those tiles are being added. And then part C says, how many tiles will there be in figure 0? That means if this is figure 1, how many did we actually start with? So go backwards. If you're adding so many tiles, you're going to take those away to show figure 0. You're going to see that we talk about figure 0 a lot in algebra. 0 is going to be really, really important as we get into our equations. Then we go into some calculator problems and order of operation problems. And you may want to write this down. Please make sure you're following PEMDAS, which you all know is parentheses, exponents. Multiplication and division, you do those in order from left to right. Addition and subtraction, you do those in order from left to right. So you can use your calculators, you can do some work off to the side, but you're going to write your answers here for A, B, C, D, E, and F. And then I want to know for part G, why are your answers for part B and D, so this one and this one, why are they different? And they should be different. And I want you to tell me what made that happen. And then for the last question, it says complete the diamond problem below. The pattern used in the diamond problems is shown. This is your pattern. Typically you want the left and the right side to help you. So you're doing something with the X and the Y to get the top. So if you look at this, X and Y is here. Something is happening between those, some math operation. I'm not going to give it away because you're going to see in the notes why I'm not giving it away. But you guys have had experience with diamond problems in the past, and hopefully this will give it away. The X and Y are directly next to each other. And then you can see what's happening here. There is a math operation listed right there for you. So how did we get the top and how did we get the bottom? You'll have to answer the first one. The second one, we're looking for the left and right. So what two numbers would I put on the sides to get a negative 36 and a 0 based on our pattern? And in the third one, we're giving you a left, but we're not giving you a right. So what would I do with that 4 to give me a negative 20 on top? And then once you find this answer, it should help you get the bottom. We have fractions here. Don't shy away from the fractions. Use your calculator, set it up, write it out if you need to algebraically. If you're not getting that one, we'll go over that in class probably on Monday when I return. All right, so that's your homework. Now using your folder that I gave you, let's open up the lesson. And the lesson always has a puzzle piece at the top. So when I refer to the lesson, you're looking for this little puzzle piece at the top as opposed to that review and preview. So we are starting with lesson 1.1.1. And it says, how can I work with my team to figure it out? Solving puzzles in teams. I'm going to read that paragraph to you. Again, if we were in class, I would be asking one of you guys to read that. In previous courses, you have looked at patterns in tables, graphs, equations. There we go. I guess my finger hit something. Let me fix my keyboard. Okay, things are really getting crazy. All right, sorry about that, guys. In previous courses, you have looked at patterns in tables, graphs, equations, and situations. So we will be doing a lot of that in algebra. We'll be working with tables, graphs, and equations, and word problems. That's what they mean by situations. In this course, you will not only continue your study of linear functions, which you have previously called linear equations, but will extend these patterns to new kinds of functions. Working with patterns will be the key to many of these functions. Note that we will define a function formally in section 2 of this chapter. In today's lesson, you and your team or your classmates will use clues in order to find patterns and solve puzzles. So now that brings us to diamond problems. Look for a pattern in the first 3 diamond problems below. For the 4th diamond problem, explain how you could find the missing numbers if you know the 2 numbers on the left and the right side. So that's what they mean here. It says, for the 4th diamond, which is this one, explain how you could find the missing numbers if you know the 2 numbers. So if you know the left number and the right number, how are you using those 2 numbers to figure out the top? And then how are you using those same 2 numbers to figure out the bottom? I'll give you a hint. You're going to use different math operations. You're going to use one operation to get to the top and one math operation to get to the bottom. So I thought I'd do something a little bit different. You can do this at home. You can do it during school. I want you to use a Flipgrid to explain how to solve the diamond problem. I set the limit on the Flipgrid to 2 minutes. so nothing to stress about. You don't have to use the full 2 minutes. It's already set up in Google Classroom. All you have to do is click it and do your Flipgrid. If you have not done a Flipgrid, I will post the directions for Flipgrids, but I'm pretty sure that these are used in most of your classes, but I will post the directions. So that's your first assignment in this lesson, is to post a Flipgrid to me on how to solve a diamond problem. Then that brings us to function machines. It says, in this problem, you will work with function machines like those pictured below. So let's remember that you have, hang on, I'm flipping to my notes here, which I thought I had all queued up, but I don't. Okay, so you are going to use the function machines to below to help you solve the problem. So it says you have x equals -1. Whenever you see an x equals something, that is your input value. So let's go ahead and write that there. You're going to use this a lot throughout Algebra 1. So your input value is always your x value. So that means wherever I see an x, I'm going to erase it and replace it with a -1. And then it wants to know, well, what does that give me as an output? That means your y is your output value. So if I'm writing notes down, you're writing notes down, and remember, you are turning these notes in for points. This way I know that you're actually doing the work. So we're going to do some work right now. We're going to take this -1 and we're going to replace this x value with it. Now remember, when you see a coefficient, which is your number 3, and a variable next to each other, the math operation that you are performing is multiplication. So I'm going to write this out for you. Y equals 3 times -1, that's my input value. Notice I didn't use a multiplication sign, I used parentheses, plus 1. We're going to show the work. Y equals 3 times -1 is -3 plus 1. And now we're going to bring it down to our final answer. Y equals, and -3 plus 1 is -2. That is our output because it's a y, and y always represents your output. So now y equals -2. But what they want us to do is they want us to drop that -2 into the next function machine. So if we're putting it into the function machine, it becomes the input. So now we have x equals -2. So we're going to take that x value and we're going to plug it in here. I'm going to slide my screen up just a little bit. So now we're going to take that -2 and we're going to plug it in where we see x. So we have y equals 2 times -2 plus 4. Because we're dropping it into the machine, it becomes the input value. So again, we're looking for the output, which is y. So y equals 2 times -2 is -4 plus 4. And we have an opposite here. So if you have a negative and a positive, we know that those become 0. So we have y equals 0, and that is our output value. The key that you need to remember here is your input value is always x. So if you're dropping it into the machine, it's an x value. If it's coming out of the machine, it is a y value. And in this case, we had a -2 come out of the machine, but then we were dropping it into the machine, so it becomes an input value as well. Sliding down. And feel free to pause this video at any time so you can continue to take notes or think things through. It says when a value for x is put into the machine, a value for y comes out. That output then becomes the input for another machine. So we're just going to take a quick little note here, and we're just going to state in a function, x is always the input. It's inside the equation. That's one way that I remember it. The x is inside the equation, while the y is always outside the equation, and that's how I remember that the y is the output. So x is always the input of the equation. And y is always the output. And if you need to write that down, that little, hang on one second, I'll write it for you. Just remember, this will come in handy later. X is inside the equation. Y equals 2x. See how it's in the inside of the equation? While y is on the outside. So think of it that way. X is on the inside, y is on the outside. That's why it's the output. All right, we're going to keep on scrolling. So now this is just a repeat of the function machines we just did. And we're just going to remind ourselves that when we put in -1, it's just the same equation that we did up here. So we're just going to remind ourselves that when we put in -1, so this was our input. We got an output that was equal to -2. Then we dropped that in, so it became an input. And then we got an output of 0. Just a little reminder of what we just did. So now we're going to have a little fun. Now this was meant to work in teams, but since I'm not there today, I'm going to kind of shorten this. It says, obtain the lesson 1.1.1 resource page. Well, I kind of made things a little bit easier for us. So I put the resource page on the next page. It says of 4 function machines. You'll see those functions in just a minute. Your job is to use a specified input to get a particular output by putting those machines in order so that one machine's output becomes the next machine's input. So that sounds a little crazy, so we're going to work through this together. As you work either independently or with a partner, discuss or think about what you know about the kind of output each machine produces to help you arrange the machines in an appropriate order. So here's the machines that we're working with. These are, it says the 4 relations are reprinted below. So these are your function machines. You have 4 function machines. The first one says y equals -2x plus 34. The second one says y equals -1x over 3 minus 10. The third one says y equals negative, and then it's got these 2 little lines right here, 3x. That is absolute, I can't spell. Hang on, let me get my eraser. This might take a minute. Hang on. It's not a, there we go. Okay, let me get my red back. So that is absolute value. I'm going to talk about that in 2 seconds. And then you have some parentheses where it says y equals x minus 2. And remember that this means squared. So we need to actually arrange these in some sort of order so that it says in what order should you stack the machines so that when 15 is dropped into the first machine and all 4 machines have had their effect, the last machine's output is -6. So we're going to start with 15, but we have to end with -6. So rather than make you go crazy, I'm going to help you with this. I'm going to actually give you the actual order so that when we drop 15 in first, we get a -6 as the last machine. That means the 4th machine that we do, we get a -6. So before we do that, I want you to go into the last page here where it says math notes. And we're going to talk about the definition of absolute value because one of those problems does have an absolute value. And it says absolute value represents the numerical value of a number without regard to its sign. The symbol for absolute value is 2 vertical bars. This is what you need to know. Absolute value can represent the distance of a number line between a number and 0. Think of that term distance. Is distance ever measured in a negative number? You can't say, I want you to travel from my house to Hudson High School, and that would be -6 miles. We never measure anything in negative numbers. So that means that your absolute value will never be negative. So here it says, for example, the number negative 3 is 3 units away from 0. So here's your negative 3, and how many units away is it? 1, 2, 3. So the distance is a positive 3. So when you write it, you'll write it this way. The absolute value of negative 3 equals 3. We could do the same thing with 5. Right here, they say, well, what is the absolute value of 5? So we're going to count 1, 2, 3, 4, 5. So the distance from 0 to 5 is 5 steps. And that's where we get the absolute value of 5 is equal to 5. So we're going to scroll back on up here, and we're going to put these in order, starting with the very first one. So there should be room at the bottom of your page, and I am going to start with number 1. Y equals negative 2x plus 34, and our input is going to be 15. So let's remember that. So wherever I see an x, I'm going to put 15. So I'm going to scroll down, and right here I'm going to write down number 1, and it is y equals negative 2x plus 34. So wherever I see that x, I'm going to erase it and replace it with our input value, which was 15. So y equals negative 2 times 15 plus 34. You can pause the video right now, get out your calculator, multiply negative 2 times 15, and you should get y equals negative 30 plus 34, and y equals, if you punch that into your calculator, y equals 4. So everybody should be punching that into their calculator. Your notes should look exactly like mine, no steps taken out, in order for you to earn your points for this assignment. So we've just finished the very first one. I'm just going to scroll up. So we just did this one, and we found out that y equals 4. So I need to now take that y equals 4, and I need to put it into another machine. So again, if you guys were in school doing this, you would kind of be doing a trial and error, but I'm going to help you guys out, and I'm going to do the next problem for you. So now we're going to take this 4, and it's going to become an input. And the problem I want you guys to do right now would be number 4. So we're going to take that one, and I'm going to write it down here. So this is the order that we're doing it in. So we're doing y equals, and the problem is x minus 2, put that in parentheses. And we're going to do that squared. Now remember, I'm going to change my color here for a hot second. We're going to use this positive 4 as our new input. So we're going to put it in for x. So I'm going to change back to red just to stay consistent. So we're going to say y equals 4 minus 2 and square it. Now remember, when you do this, you have to do parentheses first. So we're going to say y equals 4 minus 2 is 2 squared. And what is 2 squared? 2 times 2 is 4. Well, it just so happens that we got a 4. That doesn't mean that you're always going to get the same number every time you do it. But now we have a new input for our next problem. So I'm going to go back up to the top, and we're going to write down that this is y equals 4. So we started with 1, and then we went to 4. The next problem I want you guys to do would be the y equals negative, and then I want you to do the absolute value 3 times x. So that's number 3. So we're going to go over here, and we're going to do y equals absolute value. So make those lines a little bit bigger, 3x. And remember, this 4 is going to be our input. So we're going to take y equals 3 times 4 and the absolute value. So we always do what's in parentheses first, but in this case, we're going to introduce absolute value. So you're also going to do what's in absolute value first. So my negative is still hanging out here. That means I'm multiplying a negative times whatever happens to be in that absolute value. So what is 3 times 4? Well, 3 times 4 is 12. The absolute value of 12 is 12. But remember, I have this negative outside, so I have to include it as part of my answer. So my final answer for number 3 is negative 12. So up here, I'm going to make sure that we know that this now becomes our input for our next problem. So I'm going to go over here, and we know for sure that this was y equals negative 12. I forgot that. So now the only thing we have left to do is number 2. So we're going to do that one. Yep, it has a fraction, but we're going to do it. You're going to use your calculators. So I'm going to come back down here, and I'm going to squeeze it in somewhere. Number 4, and number 4 looks like this. It is y equals negative 1x over 3 minus 10. So that means we are putting in a negative 12. So right here, we're going to rewrite it. Y equals negative 1 times negative 12 over 3, whoops, minus 10. Get those calculators out. I'm going to talk you through it. I want you to punch in negative 1 times negative 12, and I want you to hit enter. You should get a positive 12. Look at your calculator screen, and you should have a positive 12 because a negative times a negative is a positive. Now I want you to do the division because remember, a fraction simply means division. I want you to divide that by 3. So you're going to get 12 divided by 3, and you should get 4. So at this point, I'm going to do y equals 4 minus 10. And remember, our ultimate goal is to get an output of negative 6. So let's see if we get an output of negative 6. So what's 4 minus 10? Use those calculators. 4 minus 10 is negative 6. Yippee. That's it, you guys. We did it. So the order that I want you to write in this space right here, we started with, so the very first one we did was y equals negative 2x plus 34. The second one we did, which is right here, y equals, and if you guys remember, we did x minus 2 squared. The third one we did was the absolute value problem, which was negative absolute value 3 times x. And then the fourth one we did was the one with the fraction, y equals negative 1x over 3 minus 10. I think that I'm going to stop there. We will pick up with this problem tomorrow. Nope, not that one. I lied. We're going to pick up with this problem tomorrow. So on Friday, this is where we will begin. Your job is to turn in the homework. You have everything that you need to do to complete the homework. So remember, you're going to do the Flipgrid, and then you're going to complete the homework that I discussed in the beginning of the class and turn that in through Google Classroom. I believe that's all. If you have any questions, shoot me an email. I probably won't be answering any emails on Thursday, but I will answer emails on Friday. So that is your homework, and those are the notes. So we will pick up with, I'll put it in green, we're going to pick up right here on Friday, and then I'll have just a little bit more homework for you guys. I'm going to flip my camera over. Let's see if this works, if I'm talented enough. Okay, I think that's it. If you guys have any questions, go ahead and send me an email. Again, I probably won't get to them until Friday, but I think we're good to go. I hope you guys have a good day. I miss you all. I'm sorry that this happened, but it just is one of those things. So I'll see you guys on Monday. Take care.